This is the first Black Hole Horizon Collaboration Telescope event on 10 April 2019. Showing a plasma or supermassive black hole at the center, galaxy M87. A bright area shows where the plasma seems to point to us. And because it's moved close to the speed of light, it looks brilliant when it comes toward us and when it dims going away. This is called beaming relativic. The plasma orbit clockwise. It takes about 2 days for the plasma to complete one orbit. Here we see. Black holes use electromagnetic waves with a wavelength of 1.3 mm wave radio. This is a part of the spectrum that is used to make image because it shows within the horizon and can pass. The ascending and insular task to reach the telescope. The supermassive black hole in M87 is very active, meaning it also has a narrow chest at the top and the bottom. It is displayed in blue, which must be made by a very strong magnetic field. The chest extends eastward, looks almost straight toward us. Relativistic beaming again, the reason that made it. We can see jets coming from the Hubble Space Telescope, but not the one that's come out, because the jet points are almost straight at us and takes perspective that almost perpendicular to increase its distance. But let's see what we will see if we look at the different orientation. Turning a space around, a black hole means you can see a light hole behind a black hole. Not to misunderstand, black holes themselves are very large. As supermassive as measured by this image, black hole has a mass 6.5 billion times that of our Sun. The actual size is almost the size of our solar system, but it's located 53.5 million light years from the Earth's perspective. Only about 40 microarcseconds that are angels made in the sky. Understanding what it means to take the whole sky and made into 180 degrees, then the degrees to Earth minutes and Earth minute to 60-second arcs, to divide 1 arcsecond into 100 and becomes 100 again and become 100 times again. That is the size the black shadows, only 40 arcsecond micro. It puts us at the limit as it is. Technology will be able to see even gets the kind of the resolution. Because for the basic laws of physics, our diffraction limits required Earth-sized telescope. That's being impractical, scientists use the 8th largest telescope in the world. They all make simulations to observe M87 as the Earth rotates with help to fill the Earth-sized telescope trying to simulate. But M87 was not the only black hole they saw. They also observed supermassive black holes at the center of the Milky Way galaxy. Sagittarius is a star, but they haven't released this black hole image. But the simulation menu shows what it looks like. It is much closer to about 26 billion light years, but also smaller than that, with only 4 million times the Sun. It is also less active, just coupling up materials on a regular basis, and it will have far more variety of over time, with material with orbiting every 4 or 30 minutes. Maybe that's why we have to wait a little longer to see the hole at the center of our galaxy. For now, a striking image of black hole in M87 confirms beyond the shadows of top that black holes do exist.